Today's lesson is on similar triangles, and we're going to be specifically discussing the angle-angle similarity. And there's one thing that we need to remember regarding all triangles. Maybe I'll write this at the top. All angles in a triangle add up to, what do you think? Can you fill in the blank? 180 degrees. We already knew that. We've known that for a long time. And that's how we're going to discuss this similarity postulate as well. So let's think about these two triangles we have here. We have one angle that's 36. This one is 36. This angle is 68. This one is also 68. So let's just subtract these two angles from 180 degrees to find this one. So we're going to do 180 minus 36 minus 68. We end up with 76 degrees right here. Okay. And doesn't it make sense that if the other two angles are the same, if you type those three numbers in your calculator all over again and do 180 minus 36 minus 68, you're subtracting the same two numbers. Aren't you going to be left over with the same exact degree measure here, 76 degrees? Which by default makes these two angles equal. Okay, so if you just think about it in terms of math, you know that in all triangles, all the angles have to add up to 180 degrees. So therefore, if two of the angles are the same in two different triangles, the third angle has to be the same because you're subtracting the same two numbers from 180 degrees every time. Okay, so let's fill in our postulate, which is in the box over here. If two angles, so that was the 36 and the 68, of one triangle, so that was our small triangle, if they're congruent, which you know is a fancy word for the same or equal, if they're congruent to two angles of another triangle, then that means that the two triangles are similar. Okay, and remember what the little symbol, I use the symbol, and we've learned this before, but this little symbol, the curly Q type of dash, I guess, means similar. It's kind of like the congruent sign without the equals part. Okay, let's look at a couple examples keeping this in mind. Are these triangles similar? Okay, well, anytime in a triangle that you're given two of the angles, I like to just figure out what that third angle is anyways. Because that's going to help me match up these triangles. Because right now you would think, well, we have two different angles that are two 90-degree angles in each triangle here. But this one's 61 and this one's 29. So automatically, without thinking too hard, you might want to say, no, they're not similar because the two angles are not equal. We do have the 90-degree angles, but let's figure out what this angle is. Let's subtract from 180. We're going to do 180 minus the 90-degree angle and minus the 61, and we end up with 29 here. Okay, well, had I not done that, I wouldn't have seen that that angle is congruent to this one. So we have the 90-degree angles and we have the 29s. So yes, they are similar, and we're going to stay the reason by angle-angle similarity. When you get into other lessons, there are other options, kind of like when we did congruent triangles. There are more options besides AA to prove triangles similar, so that's why you want to give a reason. In this section, we're just talking about AA. Alright, before we move on to the next section, let's say that somebody wanted to look at the small triangle first. Let's say that the person sitting next to you maybe decided to try and find this angle. So maybe they did 180 and they subtracted the right angle and they subtracted 29. They ended up with 61 right here. And they would have said, well, yeah, the 90-degree angles are equal and these are both 61. So they also are going to say, yes, they're similar by AA. Okay, so it doesn't matter which angle you want to find. All you need to find is two of them, because by default, what we just talked about, the third angles are going to be congruent no matter what. Okay, so I guess the caveat on this example is just to be aware that just because those two numbers, 61 and 29, are different, you might still be able to find two angles in each triangle that are congruent. Okay, example 2. Let's see if these two are congruent. Well, I'm going to swoop the 41s. I know that there's at least one angle that's congruent, and 76 is in this triangle, but you might think, well, you don't have enough information about this one, so you might want to say no. However, if you think back to first semester, one of the very first things we learned was vertical angles. You guys remember vertical angles? Does that mean that the 76 here is equal to this one? Makes this 76. These are vertical angles. Okay, so you kind of always have to be looking and remembering things that we've learned maybe a long time ago, first semester, first quarter, whatever it was. We have vertical angles here, and you have to be watching for those because those are always congruent no matter what, and the 41s are equal. So yes, these triangles are similar, again by AA, because we found two angles that are congruent. The 41s were equal to each other, and the vertical angles here are equal to each other. Okay. Let's see, example number 3, the last one. Something that's totally jumping out at me and should always jump out at you no matter what are these parallel lines. I always tell my students that in any time that you're given parallel lines, you need to be looking for angles that are congruent. Okay, so if you remember corresponding angles, the 55, that makes that part also 55. Because they're corresponding angles. Corresponding angles are always congruent. Okay. And we're not given an angle measure on this side, but isn't this angle corresponding to this one? And the parallel lines again make those equal. So anytime you have parallel lines, you got to be looking for angle pairs. And just because you're not given a number doesn't mean that you don't know that they're congruent, because they are, because there's parallel lines no matter what. So we have corresponding angles in two different places because of these triangles. Okay, so again, our third and final example, the triangles are similar by AA because we found two different pairs of angles that match up for each of these triangles. One little expansion I wanted to show you real quick. Another way that you could have done this problem is that, do you see how there's two triangles in that picture? Do you see this top one here, this little one? I'm going to draw that down here. And do you also see the big triangle? Yeah, there's a big one. I'm going to draw that down here separately. So imagine like peeling those two triangles apart. Like if this was on your iPad and they were two different pictures on top of each other, separating them out to the little triangle and the big one. So remember those red angles that were both 55? Those are still both 55. Okay, and can you see the top of both of those triangles? Let's focus right here on our picture. This angle, isn't that part of the little triangle and the big one? It's like the top of the mountain. So imagine if those were snow-covered mountains, that's where the snow would be at the top. So aren't those two angles the exact same? So I'm going to put a little swoop with a tick on those. When we peeled those apart, they're the exact same angle because they were on top of each other. Okay, so there's just another way that you could kind of look at this. If you're good at thinking in like 3D, or being able to separate out two-dimensional shapes, it's kind of another way that you can, again, we have the red angles congruent and the green angles congruent. So yes, these triangles are similar, again, in a completely different way by angle similarity. We were still able to find two different angles of each triangle that were congruent.